What if I told you multiplication can happen without multiplying? 6 times 2 equals 12. But programmers do this faster. Computers think in bits. 1 left shift doubles a number. 6 shift left 1 equals 12. Every shift left multiplies by 2. Each position represents a power of 2. Bit shifting means speed. In Python, it's one line. This is why low-level optimization loves bit operations. But wait, there's more. X shift left 2 equals x times 4. X shift left 3 equals x times 8. X shift left n equals x times 2. And now you can multiply by powers of 2 instantly. The left bit shift is your hidden superpower. But there's more to discover. What happens with right shift? Can computers find absolute value without using the absolute function? Standard conditionals are expensive. In high-performance computing, we need a branchless solution. Modern CPUs hate conditional jumps. They break the pipeline. We call this branchless optimization. The secret lies in the sign bit. If we arithmetic shift right by 31, we extract the sign as a mask. This gives us our magic formula: add the mask, then XOR the mask. Let's trace it. -7 plus -1 is -8. XOR with -1 flips the bits to +7. Why does this work? Because XORing with 1 inverts the bit. It's a conditional negation without the if. Here is the implementation in Python. Clean, simple, and brutally efficient. And in Java or C++, where bitwise operations are native citizens of the language. It's the classic battle, readability versus raw optimization. Know when to use which. Drop this in a technical interview, and watch the senior engineer raise an eyebrow. It shows you understand the machine. Remember your architecture. 32-bit integers shift by 31. 64-bit longs shift by 63. To recap, extract the sign mask, add it to the number, and XOR the result. Absolute value, solved. Next time, we'll explore how to add numbers without the plus operator. Stay tuned.